We will start day 4 by solving rational equations. I put a very simple example of a rational equation with just plain fractions, no variables. So 1/3 plus 1/3 equals 2/3. So if you notice, it's like yesterday, we have the same denominator, which we must have. And then once your denominators are the same, you're basically just adding the numerators. And I'll have you circle all of the numerators so you can see that 1 plus 1 equals 2 is a true statement. We're going to use that same concept when we're doing example 1. So you still want to factor first, get a common denominator, and then we'll solve the equation. So I'm going to rewrite this denominator here on example 1 because I see that there's a GCF of 2. So we're going to make that say 3 over 2 times x plus 3 plus 5 over 2 equals 1 over x plus 3. So if we think about our least common denominator here, I need a 2. I need an x plus 3. There's 2, we've already got that. There's x plus 3, we've already got that. So with that in mind, I don't need to do anything to the first fraction. Our second fraction, we do need an x plus 3. So remember, that's top and bottom. Our second fraction, we need a 2. Top and bottom. So once you've got common denominators all the way across, so I'm going to put this right here. Once you have a common denominator, circle the numerator, and solve the equation. So we do have a common denominator. I'm going to circle the numerators now, and that's going to create my equation that I'm going to solve. So across the top I have 3 plus 5 times x plus 3 equals 1 times 2 is 2. So we're going to solve this equation. So 3 plus 5x plus 15 equals 2. Combine like terms. We would subtract 18. So that would give us negative 16. So when we divide by 5, we get x equals negative 16 fifths. You always have to check for extraneous solutions. And the way you're going to do that is by using your restrictions. So if you look, our restriction here would be x could not be negative 3. So as long as your answer is not your restriction, then it's not extraneous. Okay, so moving on to example 2. It says solve for x and then check for extraneous solutions. First thing we want to do again is we want to factor. So I see that this is a difference in squares, so I'm going to rewrite this. Factoring out that denominator. So our least common denominator in this case would be x minus 3 and x plus 3. So here I need an x plus 3. Here I need an x minus 3. And then I have a common denominator, so I'm ready to circle the numerator and solve that equation. So I have x times x plus 3 minus x times x minus 3 equals 2. Distribute. So we'll get x squared plus 3x. Be careful here, you're distributing a negative x, so that's going to change the signs. I can combine like terms. So x squareds are going to cancel out. 3x plus 3x gives us 6x equals 2. We would divide by 6. So when we simplify that, x would be 1/3. So let's look at your restrictions. X could not be positive 3. X could not be negative 3. Again, as long as your solution is not a restriction, it is not extraneous. Okay, so moving on to example 3. We need to do AC with this problem. So I'm going to come right here and I'm going to think factors of 2 that add to be 3 would be 1 and 2. So I'm going to rewrite that denominator as x plus 1, x plus 2, because we can do our shortcut there. And then nothing can be factored across. So my least common denominator for this problem is going to be x plus 1, x plus 2. So here we need an x plus 1. Here we need an x plus 2. So again, we're ready to circle to figure out what we need to write for our equation. So I'm going to have x minus 1 plus 2x times x plus 1 equals x minus 1, x plus 2. So we're going to distribute. So 2x squared plus 2x. Here you need to either box or FOIL this. I'm going to FOIL this in my head. So x times x is x squared. Outside would be positive 2x. Inside would be negative x. So that's going to leave us positive x. And then negative 1 times 2 is negative 2. So on the left-hand side, we've got 2x squared. 1x and 2x is 3x. And then we have minus 1. So again, we're going to solve. And this is a quadratic, which needs to be set equal to 0. So I'm going to set this right-hand side equal to 0 by moving everything to the left. So I'm going to subtract this x squared. Notice how I line it up. I'm going to do it all in one step. I'm going to subtract this x. I'm going to add this 2. So on this side, everything's going to cancel to give us that 0 that we want. Here you're going to have x squared plus 2x plus 1. And then we're going to think about using AC. 1 times 1 is 1. I need factors of 1 that will give me 2, which is going to be 1 and 1. So this is going to say x plus 1 times x plus 1 equals 0. And you know you would set each factor equal to 0 and solve. So x would equal negative 1. And it's actually a double root. So you don't need to do that again. Sometimes we'll just put it like this. But remember, we need to check for extraneous. So let's look at our restrictions. So factored form of the denominator, it gets a little confusing. You may want to look at your LCD to help you with that. So x could not be negative 1 and x could not be negative 2. If you look, our solution is a restriction. So we're going to cross this out. So in this case, since that was the only one, it would be no solution.